Let's look at how we could answer this question about price versus profit. Now, the first thing we want to do is get the cost for each item. So we'll use a lookup, and then we will calculate the gross of each item, and then we'll be able to do price versus gross profit. Now I've made some mistakes here. So one of the mistakes I made was I didn't get the exact match. So I needed to add that in there. And then I had the wrong column. But eventually I got the lookup correct. And then we can just double click on it and get to the bottom. So it'll fill down really fast. So there I did clear pure. It's like, oh, I don't want clear pure. I want the cost for clear pure. So I need to put that in there too. Next, calculate the gross. So I'll figure out, it's like, oh no, I need the cost. Then we'll calculate the gross. Double click. And the gross will be the difference between the price and the cost times the units. So it's units times the difference. Then once we get that, we will look at the, we will sort by price and then by product. So all the prices are together and all the products are together. And then we will do a subtotal where for each change in price, we can get the average gross. And then that is what we will copy and paste to a new sheet and get rid of some words, kind of clean it up. And then we can do the price versus profit and see the shape of the curve, which is a quadratic shape. So we'll do a subtotal. So at each change in price, we're going to get the average gross. And then here's the data that we need. And you might scroll down and go, gosh, where does it start to change? Well, because where it starts to change from keeps getting bigger and bigger, and then it gets smaller. It's like, oh, okay, that's where we have a change in product. So here's lemon spritz, and the one just above it is the clear pure. And so the data above it is the data that we want to copy paste to a new sheet, and that sheet will be called clear pure. And what you want to do is copy it using that copy visible command. And the copy visible command is alt semicolon is the shortcut. And so what I did here is I forgot about the alt semicolon. And so when I paste this, I get all this data. I get a lot of data. And I don't want all that data. I just want the visible data. So I'll go back and fix that. When you do the alt semicolon, it looks a little bit different. So there it just selects the visible things, visible cells. And then I want to paste this so that it looks viewable. Then I want to get rid of that average. So I'm going to copy and paste that into the edit replace command to get rid of that average. Now it's starting to look pretty good. I can get rid of those two columns. So I label this price and gross, and get rid of those two columns B and C. Don't really need them anymore. And now I have some nice data to work with, and this is the clear pure data. So I can copy that. I can insert a scatter plot, and that scatter plot. Notice I'm not connecting it. I'm just putting the points in there. That scatter plot looks pretty good. We actually didn't get to high enough price, and because of some supply-demand type things going on in quarter one, it doesn't quite come down enough. So I'm trying to set the minimum to 10 just so it looks a little bit better. It doesn't affect the data in any way. So eyeballing it, you might say, well, it looks like around 25 things start to happen. So let's put in a trend line with an R-squared just to see what it looks like. And it says it's a pretty good fit, 91%. That's not bad. But you can see as the price gets higher that the variability in the profit increases. So as the price is lower, your gross profit is pretty consistent. So let's do the same calculation for the regression, only we'll use the function linest. And I've made a mistake here, so I'll use Control-Alt-Delete to enter the formula, so it's an array formula. And that's not right. And it's like, why isn't that right? It's like, oh, I forgot that I'm modeling this as a quadratic. So this is a linear, the way I have it in there now. And I want it to be quadratic. So I need to add the exponents of 1 and 2 to that function, to that array function. So there I've added 1 and 2. That means fit this to a quadratic. And now we see the coefficients that we expect. And the optimal price, by using the differential calculus, is going to be 46 divided by -2 times 0.87759. And that'll be about 25 or 26. And that'll be the optimum price. The optimum meaning that's the top of the quadratic. That's when it starts to go down. That's when the slope is 0. The slope is 0, it's called an inflection point. That's a change from going up to going down. And then what you would want to do is, if 26 seems to be about the optimal, you might want to look at the volumes associated with that optimal pricing. And you may find, well, maybe 25 is better. You'll start to see some big variances in the volumes, and you can see how many people, or how many data points we had that got this optimal price or this good price. And you can see just from the data that there's a lot of variance there as the price gets towards the optimal. So that's just something to look at. So there's a units, not a lot of units at that 26 price, or 2 data points anyway. So at the 25.99, well, there's some more data points and a little bit more volume also. So that's the general idea of how to calculate this price versus profit by collecting the data, putting it together nicely, putting it into a scatter plot, and then either eyeballing it or calculating the optimal price.